You know, every time you go online, you're using something called an IP address, probably without even realizing it. Now, I know it sounds super technical, but what if I told you it's actually as simple as mailing a letter? In the next few minutes, that's exactly what we're going to break down. I mean, really think about it. You hit send on a message and poof, it's on your friend's screen, maybe halfway across the planet, in just a few seconds. How on earth does the internet know where to send it among billions and billions of devices? Well, it's all thanks to the magic of the IP address. So, here's our game plan for today. We're going to start with a really simple comparison. Then we'll look at the two main jobs of an IP address. After that, we'll check out its different versions, and we'll wrap it all up with a super helpful revision guide to help you nail your exams.
Okay, so what's the best way to get our heads around IP addressing? Let's start with a really easy comparison. Just imagine the entire internet is one massive worldwide postal service. Right, so in this giant digital city, every single thing connected to the internet, your phone, your laptop, even your smart fridge, is basically like a house. And just like a house needs an address for mail, each device needs its own unique address so that data, our digital mail, can be sent and received without getting lost.
The system that handles all this is called the Internet Protocol, or just IP. Now, a protocol is just a fancy word for a set of rules. Think of it like the grammar that computers use to talk to each other. And this Internet Protocol has two main jobs. First, it's kind of like a city planner, giving a unique address to every single device. And second, it acts as the postal worker, figuring out the best route to deliver your data.
Let's dig a little deeper into that first big job, giving every single device its very own unique identity online.
So just like you see here, every device that goes online gets its own special address. Your laptop, your phone, that printer in the corner, yep, each one has its own. And the most important rule of all is no duplicates. It's a bit like how two houses can't have the exact same street address. Two devices can't share the same IP on a network.
Okay, this is a big one, especially for your exams, so listen up. An IP address is a unique string of numbers that identifies a device. That's it. It's like the official ID card for your computer on the internet. These are those numbers you might have seen before, something like 192.168.1.1. You'll want to make a note of this one for sure.
Awesome. So every device has an address. But how does the digital mail actually get delivered? Well, that brings us to the second huge job of IP, navigation. You can think of IP as the ultimate traffic controller, or maybe a super smart GPS for your data. When you send something online, it gets chopped up into little pieces called packets. Think of them as small envelopes. IP then looks at the destination address on each one and finds the fastest, most efficient route through all the busy highways of the internet to get it from device A all the way to device B. And here's the best part, the absolute guarantee of the system. IP is all about precision. It's designed from the ground up to make sure your data packets arrive at the correct digital mailbox. Your message to your friend won't just accidentally show up on someone else's screen. The system makes sure it hits the right target every single time.
All right, now just like real-world addresses have to change and evolve over time, so does the Internet Protocol. I mean, it had to adapt to keep up with the billions of new devices connecting to the internet every year. So there are two main versions that you really need to know about. First, we have IPv4. That's the original system. But as the internet absolutely exploded in popularity, we started, well, running out of addresses. So a new system had to be made, IPv6. This one allows for an almost infinite number of new addresses. How many, you ask? Enough to give an IP address to every single grain of sand on Earth, and still have trillions left over. It's wild.
A good way to think about it is that IPv4 and IPv6 are like two different zip code systems. Both get the mail to the right place, but the newer IPv6 system is built for a much, much, much bigger city. They're both standard protocols that make our internet work today, but the whole world is slowly but surely shifting over to the newer IPv6.
All right, I know that was a lot of information, so let's make sure it sticks for your exams. We're going to do a quick recap of everything in a simple, easy-to-remember way. If you only remember 4 things from this whole explainer, make it these. Number 1. IP has two main jobs, identity and navigation. Number 2, an IP address is a unique identifier. 3, its main goal is getting data to the correct destination. And finally, number 4, the two versions you need to know are IPv4 and IPv6. This diagram right here is the perfect summary. Seriously, go ahead and grab a screenshot of this for your revision notes. It shows you how those 4 key ideas, identity, action, goal, and types, all revolve around the main concept of IP. It really is the foundation of how everything talks to each other online.
And to make it even easier to remember, here's a little memory trick for you. Just think of the letters I, A, G, T, okay? I is for identity, the unique address. A is for action, routing the data. G is for the goal, which is reaching the correct destination. And T is for the types, IPv4 and IPv6. IAGT. Simple.
So I'll leave you with a final question to think about. We talked about IPv6 and its trillions upon trillions of new addresses. Now that you get how it works, what do you think having a nearly limitless supply of addresses actually means for our future? How's it going to change the internet and all the smart devices around us? It's definitely something to chew on. Thanks for tuning in. Ever stop and think about how your phone knows where to get a video from, or how your laptop connects to a game server? Every single device that goes online has its own unique address, kind of like a mailing address for your house. It's how things find their way across the internet.
Just think about your house for a second. How many gadgets are connected to your Wi-Fi right now? Your phone, your laptop, maybe a smart TV, a gaming console. The number adds up fast, right? Well, every single one of those needs its own unique address, and the system that hands out those addresses, it's got a big, big problem. So here's our game plan. First, we'll cover what this internet address, or IPv4, even is. Then, we'll look at its huge, but not huge enough, 4.3 billion address limit. That leads us to the great address shortage. After that, we'll check out the clever tricks keeping the internet alive. And we'll finish up with a cheat sheet for your exam. Let's do it.
All right, first up, let's talk about your internet address. This is the absolute basic building block, your device's digital ID card. Okay, so what in the world is IPv4? The name is just Internet Protocol version 4. Now, you're going to want to remember this definition for your test. It's the system that gives your devices a unique address to communicate online. Without it, your computer wouldn't know where to send or receive anything. The easiest way to think about it is like an ID card. It's the original, most widely used ID on the entire internet. Even with newer technology out there, IPv4 is still the system that powers most of what we do online every single day. And what do they look like? Well, you've probably seen these weird numbers before, something like 192.168.1.1. That format has a name, dotted decimal notation. All that means is it's 4 numbers separated by dots, which just makes it way easier for us humans to read and write. So we know what they are and what they look like. But the big question is, how many of them are there? And this, my friends, is where the story really gets interesting. The total number of IPv4 addresses is about 4.3 billion. Now that sounds like a massive number, right? But hang on, there are almost 8 billion people on Earth. Many of us have more than one device. You see where this is going? So where does that 4.3 billion number even come from? It's not random, it's just math. IPv4 is a 32-bit system. That just means the address has 32 spots for a 1 or a 0. And if you do the math, 2 to the power of 32, you get roughly 4.3 billion. That's it. That's the entire pool of addresses for the whole planet. Which leads us straight into the main event, the great address shortage. Let's look at why 4.3 billion addresses just wasn't anywhere near enough. For years, engineers were basically screaming this from the rooftops. We are running out of addresses. The very foundation of how the internet was built was about to hit a hard mathematical wall. This chart shows the problem perfectly. That flat line, that's the fixed number of addresses. It never goes up. That line rocketing upwards, that's all of us, buying more phones, more laptops, more smart everything. This collision course has a name, and it's another key term, IPv4 address exhaustion. And here's the kicker. This isn't a problem for the future. It already happened. The world officially ran out of new IPv4 addresses way back around 2011. So, wait a second. If we ran out years ago, how are you watching this right now? How is the internet still growing? Well, that brings us to the most ingenious part of this whole story. Some incredibly clever tricks that are basically the life support system keeping the internet we know and love running. It all boils down to 2 main workarounds. The first is called NATS, which is short for Network Address Translation. It's a way to share one address with lots of devices. The second is using what are called private IP addresses. Let's dig into both. Okay, so NAT, the magic word here is share. The best way to get it is this.
Your school has one public mailing address, right? But the receptionist knows how to get a package to your specific classroom. Your home Wi-Fi router is that receptionist. It takes the one single public IP address from your internet provider and cleverly directs traffic to your phone, your brother's gaming console, and your parents' laptop all at the same time. It's brilliant.
And what about those devices? They use private addresses from these special reserved ranges. Now pay attention, because this is a huge detail for exams. If you see an address starting with 10, or 172.16, or 192.168, that's a private IP. It only works inside your own home network. The best part is, millions of homes can all reuse the exact same 192.168 addresses, because they never go out onto the public internet.
Whew, okay, that was a lot. So let's boil it all down into a super simple cheat sheet. These are the key things you absolutely need to know. Here it is, all in one place. The format, 32-bit, written with dots. Its status, still the most common one out there. The big limit, about 4.3 billion, which we've totally run out of. And the fix that's saving us, NAT and private IPs. This is a great slide to pause and just let it soak in. So let's do one last lightning round recap. 1. IPv4 is a 32-bit system with about 4.3 billion addresses. 2. Address exhaustion is what happened when we ran out. 3. NAT is the magic trick that lets many devices share one public IP. And 4. Those special private IP ranges are for internal use only. If you remember those 4 points, you're golden. But it's super important to remember that all of this stuff, NAT, private addresses, it's all just a temporary fix. It's a Band-Aid on a very big problem. The real permanent solution is a completely new system called IPv6. But that's a whole other story. And I'll leave you with this final question to think about. These tricks have worked so far, but what happens when we want to connect billions more devices? I'm talking self-driving cars, smart cities, everything. Can these temporary patches hold up, or will the internet need another miracle? It's a massive challenge, and one that someone watching this might just help solve one day. Thanks for joining me. Hey everyone, and welcome. Today we're going to tackle a topic that's not just super important for your exams, but also for, understanding how the entire internet actually works. We are talking about IPv6, so let's jump right in. Well, the answer is a huge yes. Every single one of those gadgets needs its own unique address to get online. But what happens when you have billions and billions of devices all trying to connect, and you start running out of addresses? Yeah. That was a massive problem the internet faced, and it's exactly what we're going to unpack today. Okay, so our story really starts with a major crisis, the internet's address problem. But before we can get into the crisis itself, we first have to understand what an IP address even is. Honestly, the easiest way to think about it is to compare it to your home address. For a letter or a package to get to your house, it needs your specific street and number, right? It's the exact same idea for the internet. For data to get to your phone and not someone else's, it needs a unique IP address. Pretty simple, huh? So the original system for all these addresses was called IPv4. And this image here is a perfect way to picture it. Think of IPv4 as a small bucket. For many years, that bucket was totally big enough. But then came the explosion of smartphones, laptops, and all these new gadgets, and that bucket started to overflow. We were literally running out of addresses. So that's the bottom line. With way more phones and smart devices than there were available addresses, the internet was heading for a shutdown. It desperately needed a major upgrade. And that upgrade, kind of the hero of our story, is called IPv6. This was the big solution, and it was designed to fix the problem for good. I mean, this slide really says it all, doesn't it? If IPv4 was that tiny, limited bucket, then IPv6 is like a vast, endless ocean. It was designed for one main reason, to provide a massive, and I mean truly massive, new supply of addresses so we would never, ever run out again. And here it is, the official definition you'll want to lock in for your exams. IPv6 is simply the 6th version of the Internet Protocol, and its main job is to make sure we have a nearly infinite number of addresses. So, we know IPv6 gives us way more addresses, but what do they actually look like? Well, as you're about to see, they're definitely a bit longer and look more complex than the old ones. So let's break down the anatomy of an IPv6 address. Okay, at first glance, that looks pretty complicated, doesn't it? It's a long string of numbers and letters, but don't worry, we're going to break it down into simple parts. It's actually really logical once you see how it's put together. All right, the first and most important difference is just the sheer size. An old IPv4 address was 32-bit, which gave us about 4.3 billion addresses. Sounds like a lot, but it wasn't enough. Now, an IPv6 address is 128-bit. That gives us a number so big, it's hard to even imagine. We're talking trillions of addresses. It's enough for every gadget on Earth and probably every gadget on a few other planets, too.
This is a perfect breakdown of the structure. An IPv6 address is made of 8 groups, and each group has 4 characters. Now, these characters are hexadecimal, which is just a fancy way of saying they use numbers from 0 to 9 and the letters A through F. And as you can see, all the groups are just separated by colons to keep things organized.
But hey, it's not just about having more addresses. IPv6 also comes with some serious upgrades. You can think of them as its superpowers. These are features that make the internet work better, faster, and even more securely. So this gives us a great little overview of the 3 key capabilities we're about to dig into: auto-configuration, security, and better communication. Let's take a look at what each one does.
Okay, you'll want to pay close attention here because this is a huge exam tip. First up, auto-configuration. This just means your device can connect to a network and automatically get its own address. It's basically plug and play, super easy. Second, security. Protection isn't some add-on anymore. It's built right into the core of IPv6 from the ground up. And third is multicast. This is a really efficient way to send the same data to lots of people at once. Think about one live sports stream being sent to millions of phones at the same time instead of sending a separate stream to every single phone.
So, we've seen the problem, we've seen the solution, and we've seen its cool new features. But why is this all so essential for our future? Let's connect it all back to the world we live in. The biggest reason, the main driver, is the explosion of connected devices, something we call the Internet of Things, or IoT. Your phone, your watch, your TV, your light bulbs, they all need an IP address. And IPv6 is the only system that can actually handle this kind of massive growth. You know, the switch from IPv4 to IPv6 was a little slower than people expected at first, but now it is really picking up speed. And why is that? Well, because it's not really a choice anymore. As the internet keeps growing with billions of new devices, IPv6 is just essential. It has to happen for everything to work. Okay, let's do a super quick recap of the story. First, we had the problem. The world completely ran out of IPv4 addresses. Then came the solution, IPv6, with its almost infinite number of addresses, and this solution is what secures the future, allowing the Internet of Things to keep growing. All right, here are the absolute key points for your revision. Write these down. 1. IPv6 uses 128-bit addresses, much bigger than the old 32-bit ones. 2. The addresses are written in hexadecimal and separated by colons. 3. Its superpowers are auto-configuration, built-in security, and multicast. And 4. Why does it all matter? Because it's the backbone for the Internet of Things, the IoT. So I'll leave you with a final thought to chew on. Just look around you right now. What new devices, maybe things that aren't even smart today, do you think will need their own IPv6 address in the next decade? Your shoes? Your backpack? The possibilities are pretty much endless, and IPv6 is what's making it all possible. Thanks so much for watching. All right, let's jump right in. Think about it for a second. When you send a letter, you need the exact right address to make sure it gets to your friend's house, right? Well, the internet works in a very similar way, but instead of houses, we're talking about billions and billions of devices. So how on earth does that work? I mean, how does your phone right now know how to find a specific website and not some random computer on the other side of the world? The secret sauce behind all of this is something called an IP address. You know, every single device that connects to the internet, your phone, your laptop, even your smart TV, it needs one of these unique digital addresses. For a really long time, we used a system called IPv4. But now there's a new, much-needed upgrade called IPv6. And for your exams, knowing the difference between these two, well, it's absolutely crucial. So here's what we're going to cover. We'll talk about the mind-blowing difference in scale, what these addresses actually look like, and why IPv6 is generally faster and way more secure. Then we'll wrap it all up with a cheat sheet to help you absolutely ace that exam question. So let's get into it. First things first, let's talk about the single biggest reason we had to move on from IPv4 to IPv6. And it's actually super simple. We were literally running out of addresses. So the old system, IPv4, had about 4.3 billion unique addresses. Now that sounds like a ton, right? But think about it. With everyone getting phones, laptops, smartwatches, you name it, we started to hit the limit. It was kind of like a city that was just running out of house numbers. And then came the solution, IPv6. And the number of addresses it has is, well, it's just astronomical. It's 340 followed by 36 zeros. To put it simply, that number is so ridiculously massive, we will likely never, ever run out. This image really puts it into perspective. Here's the technical part you need to remember for your exams. IPv4 uses a 32-bit address system. That's what gives us the 4.3 billion. But IPv6, it uses a 128-bit address, which creates that enormous skyscraper of possibilities. This massive jump in size is a key point to remember. Okay, next question. How can you just look at an address and know if it's IPv4 or IPv6? Well, it's actually really easy once you know the secret. And this shows it perfectly. Just look at the IPv4 example. It's 4 groups of numbers, separated by dots. Simple enough. Now look at the IPv6 address. It uses both numbers and letters from A to F, and they're separated by colons. That system with both numbers and letters is called hexadecimal, and it's just a more compact way to write down really big numbers. So the key takeaway is this. If you see only numbers and dots, you're looking at IPv4. If you see a much longer address with letters and colons, that's IPv6. This is a very, very common identify the difference kind of exam question, so keep an eye out for it. All right, let's pop the hood and talk about speed. Why is IPv6 considered faster? It's all about something called the packet header. The easiest way to think about it is like the to and from label you stick on a package before you mail it. With IPv4, that header label could actually change in size. That meant the routers, which are like the post offices of the internet, had to do extra work just to figure out the label on every single package. But IPv6 fixed this with a simple, fixed-size header. It just removes all the guesswork, which makes everything more efficient and, you guessed it, faster. So to sum it up, IPv4's header is variable and pretty complex for routers to handle. IPv6's header is a fixed size and totally streamlined. At the end of the day, that means less work for the routers and a potential speed boost for your connection. So another huge difference, and trust me, this is a great topic for exams, is how devices get their IP address in the first place. See, with IPv4, you often needed someone to set things up manually, or you needed a special helper system called DHCP to hand out the addresses. It's like needing a teacher to assign you a specific seat in a classroom. IPv6, on the other hand, is basically magic. It has auto-configuration built right in. Devices can just connect and find their own seat without any help. Now we need to talk about one of the most important upgrades of all, security. In today's world, this is a massive deal, and it's a topic that examiners absolutely love. With IPv4, security was kind of an afterthought, an optional extra that wasn't always used. But with IPv6, security protocols are baked right into the system. It's mandatory. Think of it like a car. IPv4 was like a car sold without seatbelts, and you had to choose to add them later. IPv6 comes with airbags and seatbelts as standard equipment. So, the most important thing to remember is this. IPv6 was designed from day one to be secure. It provides both integrity, which makes sure your data isn't messed with, and encryption, which keeps your data private. These are built-in features, not optional extras. Phew, okay, we've covered a lot. So now let's pull it all together into the perfect little summary for your revision. You're going to want to pay close attention here because this is your exam cheat sheet. This table right here is your new best friend for the exam. Seriously, go ahead, pause here, and take a screenshot. Notice that huge jump from a 32-bit address in IPv4 to a 128-bit in IPv6. And look how security goes from not provided to provided by default. It's all here. Side by side, nice and clear. And if the table is a bit much, here are the 5 absolute must-know points. Number 1, IPv6 has way more addresses. 2, they look different, numbers and dots versus numbers, letters, and colons. 3, IPv6 is potentially faster because of that simple fixed header. 4, it's way easier to set up. And 5, and this is a big one, it is fundamentally more secure. And hey, to make it even easier to remember all the advantages of IPv6, just remember the word safe. S for spacious address space. A for auto-configured, F for fixed header, and E for encrypted. SAFE. Simple as that. So there you have it. That's the complete breakdown of IPv4 versus IPv6. I think the answer to the question on your screen is pretty clear, right? IPv6 is the system built to power the future of the internet. And now you have all the key points you need to explain exactly why. Good luck with your exams.
Hey there! Every single time you click a link or watch a video or jump into an online game, there's this whole secret conversation happening in the background. So let's pull back the curtain and find out the secret address that makes all of this online magic actually happen. I mean, really think about it. How does it all just work? It kind of feels like magic, right? But it's not. Turns out it's all about having the right address. And this picture? It's the perfect way to think about it. For a letter to get to your house, it needs a street address. Well, for the internet to send information to your computer, it needs a digital one. This is the big idea we're going to unpack today. Okay, so let's get a little more official and give this digital address its proper name. And trust me, this is a key term you're definitely going to want to remember for your exams. It's called the IP address. Now, its main job is actually pretty simple. It identifies your device on a network so that all that data knows exactly where it's supposed to go. You can just think of it as your computer's own unique ID number. But it gets a little more interesting than that. The wild part is that your computer doesn't just have one address. It actually has two of them. One for inside your home network and another one for the big, wide world of the internet. And this is such a great way to picture it. Inside your house, every single device, your phone, your laptop, even your printer, they each have their own private room number. But to the outside internet, your entire house just shares one single public address, kind of like the main entrance to an apartment building. So let's break it down real simple. The private address is for all the local stuff, like when you send a document to your printer. But that public address, that's your ticket to the internet. It's what you use for everything online, from Googling stuff to streaming Netflix. So, if all your devices have these private local addresses, how in the world do they get out to the public internet? Well, they need a special exit door. This image just nails it. Think of your home network like a big walled garden, and all your devices are inside. The only way out to the rest of the internet is through one specific gate. And that gate, that's your router. We call it the default gateway. Now, this definition is super important for your exams, so listen up. The default gateway is simply the IP address of your router. Without it, your computer is basically trapped. It can talk to your printer all day long, but it has no clue how to reach Google or YouTube. It is the one and only exit point. Okay, that's enough theory for now. How can you actually find all this secret address information on your own computer? Well, there's a really simple command for that. Seriously, it's super easy. First, just press the Windows key and the letter R at the same time. This little run box pops up. Second, type CMD and hit Enter. That'll open up the classic black command prompt window. And finally, just type ipconfig. That's IPCONFIG and press Enter. And hey, here's a quick exam tip for you. So many people make this mistake. They type ipconfig. That's a command for a totally different system. For Windows, you've got to remember, it's ipconfig. So once you run that command, you're going to see a whole bunch of text appear. I know, it might look a little intimidating at first, but don't worry. Let's break down exactly what you need to look for. First things first, you can pretty much ignore any part that says media disconnected. What you're looking for is your active connection. It's usually labeled something obvious, like wireless LAN adapter Wi-Fi or maybe Ethernet adapter. That's where all the good stuff is. Okay, the first thing you want to spot is the IPv4 address. That's it. That's the main private ID we've been talking about, with the 4 numbers separated by dots. Now, you might see a much longer IPv6 address, too. That's just a newer version, but honestly, for your exams, just focus on the IPv4 address. Right underneath that, you'll see it, the default gateway. Remember that exit door? This is its address. And that subnet mask line? Just think of it like the property lines for your digital neighborhood. It tells your computer which other devices are local and which ones are way out there on the internet. All right, I know that was a lot of information to take in, so let's boil it all down into a super fast cheat sheet, perfect for that last-minute exam revision. First up, the tool. What's the command to see all your network settings? It's ipconfig. Simple. Next, the most important term of all, the IP address. What is it?
It's your computer's unique digital identity. Third, the two different types. How do you remember them? Easy. Public is for the internet, private is for your home.
And finally, the default gateway. What is that? It's your router's address, and it is your one and only exit to the internet.
And hey, to really help you focus your studying, these are the exact kinds of questions you can probably expect to see on your exam. If you can answer these, you're in great shape. And to wrap it all up, here's a silly little memory trick to take with you. To remember the two most important bits of info, just think to yourself, I peeled grapes. The IP reminds you of your IP address, and the G reminds you of your gateway, your exit. Got it? Awesome. Good luck.